Hey everyone, welcome back to Python 101, and today we're on week 4, part 1. Yay! So, today is mainly just a bunch of problems that we're going to do on Jupyter Notebook. So, yes, let me open Jupyter Notebook. Remember, you press Anaconda, and it's going to show you an app. And make sure you press the app and not anything else, or else it's going to get scratchy. So, let me open it. First, you guys can see the thing here. So you guys can read the problem. Can it, Ross? How about you read the problem?
Keyfang's machine. Keyfang has a machine that computes the sum of all numbers given. But one day, a virus named Thorless infected it, and the machine doesn't function anymore. You, Keyfang's trusty neighbor, are paid $2 million to recode the machine. How will you do it? Hint. Define a function called myMachine that takes an arbitrary number of arguments and returns the sum. I already listened to your video about the myMachine function, so I already know the answer.
Okay. Well, in that case, Joshua, how would you attempt this problem? Like, what would you do based on the instructions?
Maybe.
So it says define a.
Check the errors, like
Hold on, let
if
me
it's
launch
like
my Jupyter Notebook. Okay, so basically, so the problem said we're gonna define what's it called? A function called myMachine that takes in an arbitrary number of arguments. And last time we made a really short but important discussion on two things. What were the two things? They start with apostrophes, but they're not called apostrophes. Do you know what they're called? Anyone? Joshua, yes.
star args and star quarks.
Yes, star args and double star quarks. Yes, you may. Thank you very much. Let me. Oh no, I meant to say new. Okay, I gotta put this over here. Python 3. All right, so first of all, remember always to do that, and then you do 4 part 1. Okay, so that's what I like to do because it's short. I used to write the whole thing, but okay, so we're gonna define a machine called myMachine, or whatever it's called myMachine. And then remember, we're gonna use star args in the argument section. Oops. Oh, I accidentally ran it. Now we're gonna return. It said we needed to return the sum of the money, so we just do sum of money, which is replaced by args. Now we can do myMachine, and then what did it say? Infected it and the machine doesn't function. You are paid to recode the machine. So basically you're paid $2 million to just fix this stupid machine. So you just do 10 plus 20 plus any number. Actually, you could just do that. And then it's gonna return the sum. Oh, I got 1988. Okay, cool. So does anyone have a question? Raise your hand if you do. Okay, yes, Ross.
Yeah, it's about like what you can use. Like, I know there's sums. Is there like any other equations you could do, like sin, cos, tan, to make like car velocity? Or
Okay, so that's physics. Do you know what sine, cosine, and tangent are?
Yeah.
What are they?
Sine is hypotenuse versus hypotenuse plus.
Okay, no, there's no plus, and okay, you got it wrong. It's actually So it's opposite over hypotenuse, and cosine is adjacent over hypotenuse. But why are you even like asking that? That has nothing to do with the question.
But my main question is, can you make stuff like subtract, multiplication, exponents, like instead of just the sum?
Oh yeah, you could write return args to the power. Oh wait, no, to the power of 2 of those asterisks, and 2. Well, you could just no. You have to do int because you can only integer. You have to do int. Oh no, but like sum is what it's mainly used for, so you just put args in here. But here you could do args. Basically, that's like what it's called. So yes, you could do here. You could do int, and then you could do x, and then you could just do x plus 1. Yeah. No, you. Okay. Wait, hold on. I typed it wrong. But yes, you can. But why would you use that when you could just do? You will print instead. You will print. So x, you put x here, and then you could do int. Okay, no, that's not wrong. That's not right. Here, yeah, you can do that, but that's not really what the problem is. And then you can even, so that's plus, that's minus, that's multiplied, that's divided. And then here, remember that's a float, and then here you could do to the power of, actually let me make it 2, and then that's that. So yes, you can do that. All right, so any other questions? Okay, because we're gonna move on to this one. So Joshi, can you read this?
Kevin's homework. Kevin is having trouble with his math homework. He has requested your help to make a program for him. The program will find the volume of any sphere given the radius. It is requested for you to make a function. Hints. The volume of sphere is V is equal to 4/3 times pi times r cubed.
Yeah.
But here pi will be 3.14. You will start the function with defined vol parentheses rad, and then
okay, so just want to make it clear, vol stands for volume and radius stands for rad. Okay, no, the other way around. But okay, so we start with vol and then rad. All right, do you know what to do next? So of course we're going to use return. Anything else? What would you do? Of course we're going to multiply based on this equation. What do you think we're going to do?
do we have to give user input?
No, the user input is rad. Rad is the user input.
So it already asked for rad.
Yes, it already asked for rad. Rad is your what's it called? Do you know what rad is?
Radius?
No. Rad is an attribute. Wait, no, not. Okay, my tongue is. Okay, so either way, it's here. You can. Oh, I learned something cool. Remember how I said you can do emojis? You can do emojis in here. But anyway, back to the problem. So return. So based on this equation, we need 4.0, which is 4, over 3. That's going to be our first thing. Do you know what we're going to put in next?
We have to multiply it by 3.14.
Yes, good job. So we multiply by 3.14, and then we multiply it by what? Oops, sorry.
Rad cubed.
Yes, so rad cubed. And now, as you can see, if we do vol and then we put in our number, here is the volume of our sphere. So minutes, you change that to 5, 6, and so on. So next up, do you guys have any questions so far? I'll take that as a no. Okay, please merge yourself, Josh. Okay, there we go. All right, final. Okay, so Lacey, yeah, Lacey, can you read this? Okay, that you pronounce that Bhuvanesh.
Bhuvanesh's tennis ball. Bhuvanesh conforms and Kevin's best friends, and he plays tennis. To win his tournament, he has requested your help to make a code that will find out which section his ball will land, and after he hits it, write a function that checks whether any hits is in a given range, inclusive of high and low. You will start with defining ran underline check num low high.
Okay, thank you very much, Lacey. All right, so Bhuvanesh is my friend. He's this Indian kid. Okay, so we're gonna help him win this tournament. Like I said, we're gonna start with some extra lines. We're gonna define ran and then underscore check. We're gonna check the number and the low and the high. Remember your colon. So now I'm gonna add a comma that says what the thing is for, because it's gonna be kind of a nasty code. So we're gonna check if the number is between the low and high inclusive. So that means it's gonna include the low and the high. So we're gonna check if the number is in and range, because that's where we're gonna use range. Low, high. I mean, it only makes sense if you use range in the range thing. And because low and high are gonna be kind of like your inputs, so they're kind of numbers-ish. Now, what happens? Then we're gonna print, and we're gonna use this string, this cool string thingy. So we're gonna do, how about we do str num plus, we're gonna use string concatenation, and then we do is in the range. Oh, hey, Quentin, you haven't been here for the last 2 weeks, so now we're just doing problems in case you're wondering. All right, and please keep your, yeah, okay, there we go. Okay, my face ran out. Okay, so that is basic string concatenation, and oh yeah, and then there's the else. So else, we're gonna print, well, guess what? The number is outside range. So that's kind of that. Now we're gonna do ran underscore check to see if it's in. So the number, Ross, pick a number.
12.
12. Okay, Josh, pick a number.
15.
Excuse me?
17.
17. Okay, we're gonna go in order, not in order. Yu Ying, who's Yu Ying? Yu Ying, please pick a number.
6.
Okay, 6. How about we put 6 here just to make it better? All right, so now we're gonna check, and let me put an ad. There we go. This should be better. Okay, so 12 is in the range. So it's in the range of 6 and 17. And of course, our brain can easily tell it's that. But like, that just defies the point of the exercise. And if you want to get the right answer, you could just print 12 is in the range. But that's just not what we want. We want to learn. Okay, so how do I, okay, Control Z, Control Z. Okay, there we go. So 12 is in the range. Good job. Okay, so recently I had some, let's just call them math problems on Khan Academy. So, oh, by the way, that we finished this one, so we don't need that. So let's give an thing. So the starting, let me do that in comments, more like comments. So the starting number is 7. The ratio, meaning you multiply, is 3. Find the sum of the first 5 terms. Okay, so Lacey, how would you attack this problem? Lacey?
I don't know.
Oh, it's okay. Quentin, how would you attack this problem? Sorry, Thoris. Yeah, how would you attack this problem?
3 times 7.
Okay, that's a start.
Okay, so 3 times 7, and then times 3 again.
Okay, so that's kind of like the logic part. But how will you put that into work? So to start, let's call the number equals 7. Okay, that's simple enough. And then we're gonna create a list called X. Okay, it's a blank list. And now we're going to use a for loop, sorry. And then for Joe Mama, and okay, no, let's pick something easier. I'm stuck here. Find a good name. For Mo, what? Hold on, I have. Okay, for Joe in range, and now we're gonna do range. But here's the tricky part. We want to find the first 5 terms. So if we do 6, if we put 5, and then to test it, we can do print 1. So here, as you can see, we printed 4 times, but we want 5 times. So we just make it 6. Now here we have 5 numbers. Now let's erase this useless stuff. So we're gonna put number times 3. Well, multiply by 3. Yes. So times 3 equals. How about I forgot if you could do multiply equals to 3, and then you could do no way, you could do just x dot append. So because x is a list, you just append, and then you can at the end you can print the and then you can print sum of x. Oh, okay, so apparently you can't do that. Equals that. New equals. Oh. Okay, so you just do this. And here is the first one. So the first number, okay, and then you print actually, you know what? Append number, and then you can do actually, yeah. Let me put num inside. No, that just doesn't do. Yeah. So, and then you add. So here, that's the second number. That's the third. That's the fourth, and that's the fifth number. So let's just keep with that. So here are the numbers, and then you can just print sum of x plus actually, let's make another. I'm kind of making this more complicated than it should be because I forgot what I did last time. But okay, so let me make another list. So y dot append the sum of x, and then I want to return. I want to print. Oh wait, no. How about I return here y? Ah no, I accidentally. There we go. What? Okay, so this thing isn't cooperating, so I'm just going to use print y. So apparently here is how our box looks like, and then you could just find the sum of it. Wait, hold on a sec. I need to check this. Hold on. There's something else. What is going? Hold on. My cat's scratching at the door. I don't know what's happening. So anyway, this I'm gonna call it out for now. For now, I'm gonna call that off. So let me stop share. Do you guys hold on? Let me. Okay. No. Hold on. I need to open the. Okay. Anyway, are you guys all in the? Raise your hand if you're in the Google Classroom. I need to see 6 hands, or else I'm not very happy. So, okay. So, 2 participants. Yes. So, guys, we have a new code here, just to let you know. Are you guys? Do you guys? Okay. So you can unraise your hand. Okay. You can lower your hand. All right. So we finished with that. All right. We have a few minutes left. So we're gonna keep talking. Oh, Quentin, I'm gonna have to stop your video. Okay, so it's taking a long time. Okay, so now we're gonna talk about OOP. So object-oriented programming allows users to make their own objects that have methods and attributes. So after defining a list, dictionary, function, and etc., you can call them to use them. So you can call an object you created with OOP. So these methods act as functions that use information about the object or the object itself to return results or change the current object. This includes adding to a list, changing numbers, and etc. It allows users to create code that is organized and repeatable. So for larger scripts or code, functions are not very organized enough and they are hard to use. Commonly repeated tasks and objects can be defined by OOP. So, commonly repeated tasks and objects can be defined by OOP, or OOP, as I like to call it, which is far more organized and usable. Hold on, if you guys haven't seen the other slides, here's the other slides. So if you think you got everything you need to know on here, just raise your hand. I'm starting to feel like my science teacher who's like this. It's like just blah 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 blah. You guys all right? And we're still writing our first words. So like yeah. Just raise your hand when you're done. But like this, I was hoping to see examples. So OOP is basically just defining classes, you know, just it's called classes. And I'm gonna show you a graph of the OOP in a second. In a second. Okay, you guys done with this slide? Okay, I'm gonna. Yes, yeah. Hold on, I'm gonna have to mute you. Sorry, man. Okay. So Joshua, you done? Ross, you guys. Okay, please lower your hands. Thank you. Okay, so here's the second. Okay, so these informations are really just like not really the ones you want. So here's the part that you really need to pay attention to. So these are the important parts. So first you're gonna define a class, and then you're gonna call the name. I called it name of this class, and then the class keyword is used to class things. Next up, the method. We define and then we use double underscore init double underscore, and here make sure there's 2 underscores, not just 1 underscore, so highlight that. And then you're gonna put self and then another parameter, and then to call the parameter you just do self.parameter equals parameter, and then you define some method and then you put the self in the thing. And then you just do print self.parameter in order to see the parameter and do cool stuff with them. So everybody on the same page or same slide. Okay, so just Ross, yes, do you have a problem or something? Do you have a question, Ross? Okay, so Ross, I think, is done copying this graph. Who isn't done with this? Just raise your hand. Okay, so Joshua raised. Okay. So this is the last one we're going to talk about so far, and let me just check my. Okay, so I think you guys are done with this. If you're not done, raise your hand. So I'm gonna suppose that you guys are done because like it's time already. So I hope you guys enjoyed this lesson and learned something. If you didn't, well, tough. All right, so as always, this will be posted on the YouTube channel, and you can review our stuff in the Google Classroom, which will be linked after I upload it to YouTube. So I'll see you guys next week, and thank you all very much for coming, and bye-bye.